Hello, thank you for joining us today. We are Warrior
That's good,
Homes
right?
and we are excited to
Yeah.
be presenting to you the home that we have designed and built for the 2020 Solar Decathlon Build Challenge. My name is Jeffrey and today, Kashifa, Gabrielle, Pierre, Ankit, Dana, and I will be presenting Warrior Homes project to you. Warrior Home is a multidisciplinary undergraduate student design team from the University of Waterloo, which is located in Waterloo, Ontario, Canada. We are the only Canadian team participating in this year's Build Challenge. Warrior Home designed and built a net zero energy home on the Chippewas of Nawash's Nishnigming Reserve in southwestern Ontario on Bruce Peninsula, which is between Georgian Bay and Lake Huron. The 4-bed, 2-bath bungalow is part of a new 19-house Kaikainon subdivision being built by Habitat for Humanity Grey Bruce for the Chippewas of Nawash's Band Council to use as homes for their new affordable rent-to-own housing program. Warrior Home worked closely with the Chippewas of Nawash on the design of the home. The community had asked for homes that allowed for multi-generational families to live together. Warrior Home's spacious and accessible design allows for just that. As the house was built on a reserve for an affordable housing program, our home was not sold on the open market. However, our partners have told us that other Indigenous communities have expressed an interest in using our design on their own reserves because of its easy replicability, affordability, quality, and sustainability. The team was also able to work closely with Melissa, the identified future homeowner, on accommodating the unique needs of her family. One of Melissa's 4 children suffers from visual impairment. After the team learned about this, we added a number of accessibility features, such as extra lighting and guide rails along the walls. The home broke ground in June of 2019, and by November of 2019, construction was complete and a dedication ceremony was held. Melissa and her 4 children moved into their new home in December of 2019. Warrior Home was one of the first teams in the competition to finish construction. Warrior Home was inspired to take on this project because the team wanted to tackle one of the most pressing and difficult housing challenges in Canada. The inadequacy of housing on Indigenous reserves in Canada has made national and international headlines. According to Statistics Canada, some 42% of homes on Indigenous reserves in the province of Ontario are in need of major repairs, and approximately 1 in 5 people experience inadequate housing on reserves. The Chippewas of Nawash First Nations community on the Nishnigming Reserve are experiencing a growing and urgent need for housing as more band members are choosing to return to the reserve. Warrior Home's completed project demonstrates that there are potential solutions to Canada's Indigenous housing crisis. Not only does our home provide a family with adequate and affordable housing that accommodates the unique needs of their Indigenous family, it also is a sustainable net zero energy house that was simple enough to be built by Habitat for Humanity's volunteers.
We cater to the specific needs of the Indigenous community by including features such as gathering spaces and native vegetation. The house is one among many backed by a large cedar forest. Nature and community are united in the Grand Common Room as the occupants can see both the forest in the back and other neighbors at the front in one room, perfect for family and community gatherings. The home is divided into green private space and blue common living space. A corridor easily divides the bedrooms from the common space, providing the family with maximum privacy. The washroom for these rooms uses a door to separate the toilet and shower from the sink vanity. In comparison, the central washroom, common space, and integrated mudroom are situated to allow both accessible and adaptable accommodations. Using the closet space, the central washroom can be redesigned to be more wheelchair friendly if needed in the future. The integrated mudroom and laundry room acts as an intermediate space between the outdoors and indoors. With direct access to the laundry room and bathroom, dirty clothes and other external factors never reach the living space. Interior design focused on using sustainable and resilient materials to maximize the comfort within the home and minimize costs as well as energy consumption. From laminate flooring to low VOC paints, as well as low flow plumbing fixtures, these materials are affordable, durable, and pleasing to the eye. Lighter colors selected allow for passive lighting as well. Energy Star appliances were chosen to reduce the energy consumption within the home.
The building enclosure plays a vital role in meeting net zero, as the more efficient, airtight, and thermally insulated the enclosure is, the lower the mechanical loads required to condition the home, and henceforth, the lower the energy and monetary requirements. The enclosure design was influenced by the constraints placed by our stakeholders, such as the limit of 2 inches of insulation on the exterior, as well as the need for a design to be easily constructed by a mainly volunteer workforce. Beginning with the roof, the ventilated roof assembly makes use of a raised heel truss. This minimizes thermal bridging at the exterior wall-to-roof interface by allowing for increased insulation around the perimeter of the roof. The thermal performance of the roof assembly comes from R70 of loose-fill cellulose insulation. A 6mm poly sheet mechanically fastened to the ceiling joists acts as the air barrier, and a 6-foot wide ice and water shield running along the perimeter of the roof as required by local code, as well as a synthetic underlayment for the remaining roof area, encompass the water barrier. Moving on, the exterior above-grade wall assembly consists of vinyl siding secured to 1x3-inch furring strips, spaced at 24 inches on center, with 2 inches of EPS on the exterior. This is followed by Tyvek, mechanically fastened to OSB sheathing with tape joints. We chose to use OSB with tape joints as the air barrier to increase the likelihood of maintaining air barrier continuity during construction, as Tyvek is prone to small tears. Interior insulation between the studs consists of 5.5 inches of fiberglass batt insulation, followed by an interior gypsum board finish. Thermal analysis was also conducted using Therm 7.6 to ensure there were no concerns with regards to thermal bridging and to confirm the adequacy of our design for our various assemblies and assembly transitions. We also conducted hygrothermal modeling in WUFI using the worst-case scenario interior and exterior conditions. On the graph above, the blue line is the interior moisture content, and the green and gray lines are respectively the indoor air dew point and the temperature of the interior face of the OSB sheathing.
The energy consumed for heating, cooling, and hot water production account for about 60% of the annual energy consumed in the average North American home. Therefore, unique solutions were required to decrease the home's energy consumption. This includes the additional challenge of designing a system that will be serviced locally and is still efficient in the extreme cold conditions experienced during the winter. A Coleman air source heat pump was selected to provide heating and cooling for the home. This system uses an outdoor compressor connected to a ducted air handler and evaporator coil located in the crawl space. A backup electric element is also included for when the unit is less efficient during extreme cold. This system was generously donated by a team sponsor. Due to the home's tight building envelope, constant fresh air ventilation is required to ensure occupant comfort. A heat recovery ventilator was installed to accomplish this task. The HRV was chosen over an energy recovery ventilator, as it will ensure moisture isn't transferred during the humid summer months. Domestic hot water is produced by a hybrid electric heat pump water heater. This energy-efficient unit saves over $5,000 in electricity over its lifespan, helping us reach our goal of net zero energy. A PEX piping system was used throughout as a simple alternative to copper plumbing. The manifold allows for even pressure distribution and simple serviceability. It's also the most cost-effective system to purchase and install and has a long service life. Smart home technologies were also implemented throughout the home to allow the residents to understand and monitor their usage. A Nest Gen 3 learning thermostat allows for simple temperature control and automated schedules. The flowy water sensor tracks domestic water usage and can alert residents in case of a broken pipe or leak before any serious damage occurs.
As you've seen, our mechanical and building enclosure systems are designed to improve the energy efficiency of our home. However, in order to meet net zero, we knew there needed to be some kind of energy generation occurring on site. With this in mind, we aimed to design a system that was cost-effective over its entire life cycle, made use of local utility programs and the existing environmental conditions. Enabling and encouraging the occupant to operate the renewable system is critical as other aspects of the design, such as heating, depend on electricity, which is only economical when the occupant is generating electricity at a cost lower than natural gas. Further, we wanted to ensure that the home was resilient in an emergency, benefited from the grid, but was not reliant on it. Ultimately, a grid-connected 37-module rooftop photovoltaic system was determined to be the best solution. As our home is grid-connected, we are taking advantage of the local electricity provider's net metering program. In the daytime, any excess electricity generated is given to the grid, and at night, any energy used will be pulled from the grid. At the end of the month, if our home gives more energy than it uses, the occupant will not be charged. Our home was able to achieve a Hearst index of 39, based on the energy efficiency improvements made to our design. With the incorporated solar PV system, the Hearst index drops to -14, proving net zero capabilities. Through modeling, comparing our design to the current home being built by Habitat for Humanity, the energy performance improvements are significant. As you can see, on an annual basis, our design has an energy use intensity of 90.5. This is less than 2/3 of our baseline home amount of 169.4.
Since affordability was a huge consideration throughout our design process, we chose durable, cost-effective materials. The as-built cost of 220,000 Canadian dollars was only slightly higher than our estimate of 212,000 Canadian dollars. As for operational costs, the approximate monthly cost to the homeowner is about $650 per month. The agreement between Habitat for Humanity and the Chippewas of Nawash limits the monthly mortgage to 30% of the family income, which is about $500 per month. After 20 years of paying this mortgage, the ownership transfers from the band council to the family. Throughout the build challenge, the Warrior Home team was able to build relationships with the Chippewas of Nawash community and produce a finished product that was simultaneously tailored to Melissa's family and replicable for future projects. The entire project has been an amazing opportunity to bring together students from different disciplines to work together towards a common goal. Warrior Home is so proud to have designed and built this house for Melissa and her family, and we look forward to our future endeavors. If you're interested in learning more about our design, you can check out our website or our social media pages. Thank you.
Thanks, Warrior Home.
Awesome. Thanks for listening.
Thank you.
I put a few questions in the chat. Are you open to questions?
We would love questions.
Yes.
I'll put one out there, but certainly I know we have a couple of other folks on as well. But I was wondering if you have, since you all were the first to finish and you've had a family in the house now for well over a year, do you have data on the actual performance of the home compared to what you expected it to be?
I believe it is doing quite well. I don't know if we actually got the precise numbers. I know from talking to the homeowner at the beginning, there were some issues first getting things set up, but then afterwards, I don't think she's had to pay very much at all, if anything, afterwards for her utilities, for her electricity. So I think it's been going quite well for her.
Fantastic.
Mm-hmm.
The other question I typed in, go ahead, Jeffrey.
Oh, no, I was just gonna
answer the other one. Yeah, I mean, I was just wondering if you had a number. Obviously, you put in some more efficient equipment that's more expensive and you have the panels and so forth. Do you have a sense of what the increased cost was over the standard home that could have been built on the site?
Mm-hmm. So our home was a little bit more expensive than the standard house, but not much more, especially with all the panels and things, not much more than what our team was able to cover with a donation that we made using the $25,000. So it really is basically just that it converted to Canadian dollars, 30,000 Canadian dollars more than that standard house.
Got it. Okay, great.
Mm-hmm.
Great. Well, I will jump out and let you guys do your tour again if other folks come in. Thank you so much.
Thanks so much.
Question.
For sure.
Yeah, I'm Adam. I'm with Site Selection Magazine. We're in Atlanta, Georgia. I'm working on a project over the next 6 months about career and technical education as it relates to renewable energy technology and building of projects such as this. So I'm interested. I mean, I'm familiar with University of Waterloo and the tremendous resources it has. What types of resources are there in career and technical education that relate to this type of construction project, either in the vicinity of your university or in the vicinity of the First Nations community.
So in terms of educational resources or like professional kind of development in that sense?
Yeah, I'm thinking in terms of skills training and certification for
sure.
specific types of work in these fields. And I'll
So
mute myself.
Our co-op is definitely the greatest asset for that kind of request or question. The university's engineering program is all co-op based, so students rotate between learning and working almost every other term depending on their program. And by the time we graduate, we have 5 or 6 real life work terms in the field of any industry we can choose to work in, basically, and they support us through the job search and selection process. So personally, that's been the greatest attributor to my knowledge and extracurricular knowledge and learning outside of the classroom, because really learning what you learn in the curriculum only takes you so far, but in the workplace what you need is what you learn on your work terms or on your design teams, because there's a bunch of other design teams other than ours. We have steel bridge teams that do more civil work and stuff like that, so that's really what I think sets us apart. So open it up to anybody else.
I would say it's really special at Waterloo how we get 6 different co-op terms. So you might have a co-op term in like estimating, you might have a co-op term in like building science, and you get all the knowledge from different disciplines. And if your employer is one of those super nice employers, you might get like some special training. Like at one of my co-ops, they were like, does anyone want to do working at heights training? I didn't do it because I'm afraid of heights anyway, but there are like opportunities through co-op to get special certifications and stuff that you might not get just from a regular engineering degree.
And the lunch and learns you get at the consulting firms and stuff when the companies want to kind of buy your business. So you learn a lot about new technologies, whether it's like car chargers or mechanical systems. These big companies will come in and speak to us and really teach us about their product and what they offer on the marketplace.
I guess I have a related question, which is, do you see an opportunity for some of this skills training specific to the building of sustainable homes like this being extended to people in the First Nations community? In other words, to see some actual workforce development within the First Nations community related to these fields.
Mm-hmm. So on that question, I guess one other thing that all the students were able to do was to go and volunteer on these build sites. So that was a lot of skills development for our part, but also for the First Nations community, they were also able to join in and get some workforce development and skills training from this project as well. And I believe even beyond just the community that we were working with, there were also people from other Indigenous communities who came to the Nishnigning work site to really get some of those work skills and learning experiences and to develop their skills working with these sustainable housing development projects so that they could apply them in their own communities. So there definitely was that opportunity here with our project.
Definitely, and the learning curve associated with the green technologies, I think, was something that we had to address in the whole development process. Like there was a lot of details that we had designed in terms of air sealing around windows that kind of were put forth and used further on in the construction process within Habitat for Humanity and their housing community authority to kind of implement these educational resources in a broader sense, even for home usage monitoring and how to operate a house more efficiently. It may be designed to be efficient, but if occupants aren't properly maintaining equipment, even just basic tasks like changing filters makes a huge difference in the efficiency of a lot of these heat pump equipment. So that is another, I guess, educational resource that we can provide to these communities on top of what they can learn elsewhere.